This video is for running R and RStudio in a Windows operating system, and we'll cover the basics of how to run your first t-test. In a previous video, I showed how to install R and RStudio and how to set the working directory, so we'll start there. So I have R and RStudio open right now. R is running in the background, and so I'm just using RStudio as an interface. I've already opened up my script file, this antibiotic t-test file, and I have my folder selected here in the bottom right pane that has all of my files that I've downloaded from Canvas. So I'll double check that my working directory is set to this folder because this is where I want to save new files to. I clicked the gear icon where it says more, and then I just set this as my working directory. If you need help getting to this point in the video, please see the prior video on how to set up your computer for R and RStudio. So now we'll start running this script that has code in it. Up here in the top left pane, this is where we can edit lines of code. The first few sentences have a pound sign or a hashtag at the beginning. That means that that line is commented out and it will not run. There's no data or code to run in that line. It's just some information that we've kept in there, some notes that we've written for ourselves. And so that hashtag is really important at the beginning of that line, so that way RStudio is not going to run it as if it were code. Our first line of code is down here, line number 7, where it says library ggplot2. You may need to install the ggplot2 library, and to do that, you can come down here to where it says packages, and we can click the install button and search for ggplot2. And then you would be able to install. Make sure that you have this box checked where it says install dependencies. I already have ggplot2 installed on this computer, so I'm just going to cancel that. To run this line of code, I will hit the control button and enter at the same time. You can also click this button up here where it says run, and it will just run that line of code. Okay, now I have my library loaded. And the next thing, it says step 1 is to set the working directory. I've already done that using that gear icon, so I can skip past this. If you want to use this line of code instead of the gear icon, you can. You just need to update this file path to the path where your files are stored on your computer. Okay, step 2 is to create this object called antibiotic zones. And this is going to be a CSV file that we have saved in that folder. And the antibiotic t-test data has data that the class has collected on zones of inhibition in a Kirby-Bauer test with different species of bacteria. So I'm going to click anywhere in this line 14. It doesn't have to be at the beginning, and I'm going to press Control Enter again. So you can see down here that I have run that line of code, and I have created this object called antibiotic zones. That object is going to appear up here in the environment pane, and I can look at that table that I've just imported by clicking on it. When I click on it, it will appear over here in the top left pane. So you can see in this data file, I have 2 columns, one with bacterial species and the other one with zone diameter measured in millimeters. In my bacterial species column, I have 2 different species, E. coli and Staphylococcus aureus. And then we have different zone diameters measured for each of those species. In this column, we just have numbers entered. We don't type in the letters indicating units. They are already part of the column header, so they're in the title of that column. We can click back over to our script file here and move on to the next step, where we are going to double check the structure of that file that imported. So str is the function that indicates structure. So we'll look at the structure of that object by clicking Control Enter to run that line of code. Now we get some information down in the console pane about that object. So it is a data frame. That's like a type of spreadsheet that has imported into R. There's 10 observations which checks out because I know my class measured 10 different plates of the Kirby-Bauer test. And there's two variables, meaning there's two columns in that data frame. The first column is called bacterial species. It's a character variable indicated by CHR. And we get a little preview of the first few characters in those first few rows in the table, and they're all E. coli. The next column is called zone diameter. This one is an integer variable. And we see the first few rows of integer data present in that column. This is really important. In order to do our statistical analysis later, we have to have integer or numeric as the type of variable for this column. We won't be able to do any analysis on it if it's a character type variable. If you do run into that trouble, I have another video uploaded for troubleshooting your t-test in R. The next step is to look at the levels that are present in these variables. So we want to look at the bacterial species. We want to make sure that we only have 2 bacterial species present in our table because we're going to be doing a t-test on those 2 species. So our levels function is going to check within that object antibiotic zones. It's looking within that column bacterial species. The column name appears after the $ symbol. Okay, so here's our 2 levels, and this is good news for us. There's only 2 levels. If you have any issues with typos, this would be a good place to pause, open that file back up in Microsoft Excel, and update column titles or any of the data within the cells. That way you can make sure that you're going to be analyzing the quality controlled data set. Okay, so our next step is to do the t-test. So this function here, t.test, will run our t-test. And the way this function is set up, we have our dependent variable, zone diameter, and then a tilde, and then our independent variable, the bacterial species. The data that we want to run this analysis on is found within that object called antibiotic zones. So now I can run this line of code. And I get some results output down in the console from that t-test. Your laboratory GTA is going to help you interpret this result. We have the t-test statistic printed here. We have the degrees of freedom for this analysis next. And finally, we see the p-value. In this case, it's 0.000214. That's less than 0.05, and so we will interpret that as a statistically significant result and that the 2 species have different zones of inhibition. We also have a mean published down here for each of those groups. So E. coli had a mean diameter of 10.8 and Staph aureus had a mean diameter of 17.0 millimeters. Okay, our next step is to graph this result. So we're going to make a t-test graph. And again, we're creating an object, t-test graph. Next to that is the less than symbol and a hyphen. Together, those two create what is referred to as gets within R. So the t-test graph is going to get the rest of this information here that's on the right-hand side of it. In other words, we are assigning all of this plotting code to that object called t-test graph. So we'll use ggplot as our function, and within ggplot, we need to give it some information about what to plot. So it will be plotting the antibiotic zones data object that we created earlier, and then we have some aesthetics, AES, that are specified. So we will specify that on the x-axis, we want to have bacterial species. On the y-axis, we have zone diameter. These column headings are not exactly what we want those axis titles on the graph to look like because we don't want to have all of the different periods and the way that it is printed here to appear exactly on the axis titles. So we also want to update what those axis titles will look like. We can use a plus sign at the end of this line of code so that we can add more features to this plot. The next feature we'll add is the box plot function, and your laboratory GTA will explain how to interpret the box plot. We're going to fill those box plots with two colors because we're going to have two different boxes, one for E. coli and one for Staph aureus. You can either have one single color listed here, so then all of your boxes will be the same color, or you can have a number of colors that is equal to the number of variables that you are plotting. Then we have our X lab, which stands for X-axis label. We'll call that bacterial species. This text is within quotes. That's very important. xlab is a function and it requires any kind of text label to be enclosed by quotation marks. So make sure you're not missing the quotes. Then we have a y lab or y-axis label. And now we have our antibiotic name, zone diameter, and this is where we're going to type the units for that label, millimeters. You might have a different antibiotic that you measured for your experiment. Then after that, I'm going to add the black and white theme from ggplot. This is a suite of parameters that are pre-programmed into ggplot. And I really like the black and white theme because it has a very minimalist look to it. On top of that theme, I'm going to specify some parameters that are unique and maybe different from the black and white default theme. So I'm going to include for legend position, I will say none, no legend. I don't need a legend for this type of plot. If you did have a plot where you wanted to have a legend, you could instead type top, left, right, depending on what part of the plot you want the legend to appear on. And you would put that right here within these quotes. Next, we have the option to have a grid on this graph. I think that grid lines are distracting, and a lot of journals, scientific journals, also agree that grid lines can be distracting to the viewer's eye. And so I am going to keep the grid lines function as blank. So there will not be any major grid lines or minor grid lines on my plot. Then I'm going to specify that I want a blank background. I just want to have a black border around that background. And I want to have a basic white rectangle serving as the background for my plot. So again, a very minimalist aesthetic. Then for my axis title, this is going to be the x-axis label or the y-axis label text. I want to have that font size 14. This will be good for me to put into my paper. If I was creating this for a PowerPoint presentation, I might increase that font size to something larger than 20, for example. The axis text, this is going to be all of the different labels for the axis. So this will be where we see E. coli or S. aureus published at, and I want that font size to also be 12. And the x-axis text, I want that element to be italicized because I'm working with scientific names and it's standard to italicize scientific names. Okay, now that I have walked you through all the different parameters within our ggplot, I'm going to put my cursor up here in line 28 and hit Control-Enter to create that graph. Now we don't see the graph yet because we haven't called that object. The next step is on line 36 to call the object by hitting Control-Enter again. And now we see that that graph has populated down here in the lower right-hand pane. Why did we need to create an object name for our graph? Well, later, if we want to do things with this graph or save it or insert it somewhere, it's much easier just to call it by the object name instead of writing all of the information again for creating that ggplot. So it's a lot easier just to create an object and assign it all of those plotting parameters. So here's my graph preview and it looks great. I've got italicized text on the x-axis for my bacterial species. I have an orange box and a blue box representing the two different bacteria, and I have my y-axis label. So now finally I can save this file using the last function called ggsave. It's going to create a new file within that same folder that is my working directory. And this file, I can name it here within quotes. I do want to create a JPEG type of file. I'm going to use that t-test graph plot to save it as that new file, JPEG file. And for this graph, I want to make sure that it is 4 inches by 4 inches in proportion. You can change these numbers if you're creating a graph that will be displayed in a presentation. Maybe you want to have a larger graph for that purpose. So you can change those dimensions there as you want. So now within this line number 39, I can hit Control Enter, and I've got a new file saved. Back in my Files pane, I'm able to find that file. It's going to be right here, antibiotic example ttest.jpg. So if I navigate back to that file, which is within a folder on my desktop, I'll be able to find that same image, and I can drag and drop it, or I can just copy and paste that image into the worksheet file that accompanies this exercise. If you ran into any problems going through the t-test script with me in this video, you'll want to watch the follow-up video that goes through some troubleshooting steps for some commonly encountered problems while trying to do the t-test.